print whatever you give them. So you can just make them more and more absurd every single time, and they will keep printing them. Okay, so I'm going to end up talking really fast because I have way too much content. So the way to follow along with this is don't try and take notes. All the slides and videos and stuff are going to be available. And there's lots of bullets that go along with each slide that you can come back to later. So the idea is, oh, there's that thing that I heard about that I want to research more about, and then go research that. All right, because I thought I had 60 minutes, and I've got like 40 less an introduction. So this will be fast. So an opinion that I've told lots of people, even those that haven't asked. Browser-based automation was largely solved about 6 years ago. Flakey tests, shaping traffic, all those fun things. We know how to do them. We haven't necessarily communicated them well, but we have more or less solved all these problems. The thing that doesn't get talked about is the infrastructure and the operational procedures around where your automation runs. And I think this is a really big thing that needs to be discussed because that's where the business risk is it's the infrastructure that your scripts run on. If you figure 40 million people that shop at Target had their credit cards compromised via an air conditioner, I guarantee you that somebody has had their corporate networks compromised via their automation environment. If I was a bad guy, you can be damn sure that that's the environments I would be going after. Because the pattern I've seen in 20 years of doing this stuff is typically you take a good tester and you make him a crappy programmer, or you take a good programmer and you make him a crappy tester. Nowhere in there is there a ops phrase. They log into the Amazon console, spin up an instance in a public VPC, which is by default the same visibility as the subnet it's in, which is usually public, and now your application is running on the internet through security, via obscurity, which is not really secure. So the infrastructure is really where I care about. I really don't care about how you write your scripts. Where you run them, I care a lot about. So when I talk about what does automation infrastructure mean, there's really three big buckets. There's the automation framework itself, so your scripts, your runner, the drivers, like the WebDriver plugins and such. There's the actual application that you're running your tests against, and then there's the third-party stuff that isn't really in your control, but GitHub, Sauce Labs, Travis, Circle CI, all those things are part of your infrastructure. And they're actually things that you have to punch holes in your firewall for, which is, by definition, making your environment less secure. So I gave a talk in Austin 2 years ago, which was rambly even by my standards, which is saying a lot. And then a couple weeks later, I discovered Amazon has this thing called the Well Architected Framework, which is really a sales tool from the AWS folks, where it says, here's this thing that you should think about, and by the way, here's how you solve it using Amazon tools. I don't work for Amazon. I just think it's a really interesting framework, especially if you sort of ignore the, and here's how you solve it with Amazon tools. It becomes really cloud neutral. It doesn't matter, the same principles apply in Azure or GCP or AWS or whichever other cloud provider you want. It's all available for free on their website. It's a PDF, it's 65 pages, costs literally $7 to print with a nice glossy cover. I highly suggest everybody spend that $7 because it's really good to just sort of pick up and like, oh, what do I want to think about today? Oh, here's this thing. Now I can go look at it. So that's my sole use of props. So the AWS framework is broken into what they call 5 pillars. Operational excellence, security, reliability, performance efficiency, and cost optimization. Inside each of these pillars are a number of disciplines. So I'm on slide 5 of 38, which tells you how many disciplines there are and how fast I'm going to be talking. Again, don't try and memorize all this stuff. So operational excellence is the first pillar that they have. And if you have an existing environment, which I am going to hypothesize that most of you have an existing environment, there's probably not too many people that spent the money to come here of like, I've heard about this Selenium thing. Maybe I should go explore it and see if I want to use it. This one is the biggest pain in the butt to backport into an existing environment. If you are starting a new environment, it's easy peasy. Less so for an existing one. Especially because the very first pillar, the discipline they have in the very first pillar is all your operations need to be done by code. And this is common in this continuous delivery community, but it's still got to work its way back into, and this is where I'm just going to pick on entire industries, like insurance companies may not be doing, okay, non-insurance companies, do we have a better one? Cruise line industries. Okay, let's go with that one. Apparently I'm not allowed to pick on insurance companies. So that sort of stuff may not have filtered down into the testing departments yet. And there's really three types of operations that you need to think about. One is orchestration, so that's lighting up the actual instances or in containers. And each of the cloud providers have their own tool for that. But I would actually recommend you look at something like Terraform, which is cloud neutral, because even though your application may be only running in AWS, if you want to run it on real Mac devices, which don't run in AWS, you need to use something like Mac Stadium, which uses VMware and needs to be integrated that way. So suddenly, even though you're using AWS with CloudFormation, you need this other third part, so you need another tool. So for your automation infrastructure, I might look at a cloud-neutral tool like Terraform. Once your thing has been lit up, you need to configure it. Put this package here, open up this port, a little bit of networking, mount this file system. That's configuration. So Puppet, Chef, Ansible, Salt. There's a million of these little packages around. Which one you choose, I don't care. Just use one of them. And then if you're interacting with your infrastructure, which you will, use whatever tool that the provider has for management of this stuff. So you should never, it's a sort of a bad idea to ever log into your EC2 instance, for instance. There's a horrible use of words. So anytime you have to log into a box, it is a smell that you haven't automated something. Don't log into the box to look at your logs. Funnel your logs off to a third-party place. Don't log in to run a configuration command. Have that scripted so you can run it against it. Amazon has the system manager, for instance, as a category of tool. And now we go into ones that we start to fly through. All of your configuration management tools, be it Puppet or Terraform or CloudFormation, have some way of putting comments into your actual code to say what it's doing. And if you do a search on Google for like tool name generate docs, somebody has written a project that will take those comments and emit out HTML, so that way your documentation every single time you check in is updated. Because again, we're treating our configuration as code, it gets checked in, it fires off a continuous integration job, checks all the code style that you have, generates your docs. So your docs are always up to date on how to generate your infrastructure. Because there's a hit by the bus factor there that you don't necessarily want to, I've got all these scripts, but nobody knows how to run them. So if that's the case, then you might as well not even have the scripts. This one should be obvious for this audience. Make frequent, small, reversible changes. Don't do, I changed 47 things and something broke, and I don't know which one because I did 47 things all at once. Because that never happens to us as testers. The changes always come from the developers in nice little discrete packages. So one thing that when I'm doing consulting, I look at the commit logs. And if I see the word "and" in a log message, that's a code smell. It's the same thing that happens for your infrastructure, that if you are trying to do some changes and you're pushing it up to GitHub or whatever, or your internal Git server, and you say, and something else, you probably should rethink about what you did because it's too much to push up and test. Unless it's something like, and I'm an idiot because I forgot to push a file, because that never happens. So this one, again, refine your tools frequently. I've got a block of time in my calendar. It's the third Monday of every month. The afternoon is blocked out for go through the Puppet modules that we use to double check, is there new versions and that sort of thing. So because I used to not do that, and then I had to update a module, and I lost 2.5 days of module dependencies and rewriting all of my manifests and such. So just like literally block time out in your calendar to double check, is there a new pattern that I should be using? Is there, are the tools have been updated? Audit these things and literally block it out in your calendar. Anytime you have a cloud environment, you need to really anticipate failure because it'll come literally by definition when you don't want it to. So you just need to accept it if you're running your stuff in the cloud, that an instance is going to hang for no apparent reason. Or better still, you get the notice from Amazon saying, tomorrow at 2 p.m. we are going to shut off your instance because we've noticed performance degradation. I hope that you have a plan to replace it. Because they aren't going to wait for you to oh no, we don't have that script, or that's Bob's job to configure the servers and they're away. Accept that this stuff is going to go away inconveniently. But you can use tools like Chaos Monkey, which is an open source tool, part of the Simian army from Netflix, which will just randomly turn off stuff in an environment and see how it self-heals, because it's the cloud. So it can be things like, there are supposed to be 2 instances up that look like this. This one went away. Oh, well, let's bring up a new one. And because you've got all your configuration as code, it just happens automatically. And it all self-heals. There's all sorts of fun story of Facebook went to the London data center and basically went to the wall for the power that came in and turned it off, and nobody noticed because they do all this self-healing chaos engineering. It's a really fun space that's starting to grow. So accept that it's going to happen and figure out how to have your environment self-heal. And sometimes you don't anticipate everything. Failures happen unexpectedly, and that's okay, because it's not a mistake unless you didn't learn from it. So if mistakes happen once, they happen again, to kind of raise an eyebrow, really, we didn't learn from this, we didn't prevent this. And if the same failures happen over and over and over, infrastructure-wise, then there's going to be conversations. So that in 13 minutes was the first pillar. Security, this is a lot of what I talked about in Austin, because this is really, really freaking important. And a lot of environments are not secure. So very quickly, anytime a human is interacting with your cloud infrastructure, setup and management stuff, there needs to be multi-factor auth in place. Let's just accept this as gospel and move on. If you're using tokens, make sure they're short-lived, practice rotation, because those tokens will get pushed to GitHub. I'm not going to tell you the search query or suggest that you do it, but if you look for .aws credentials on GitHub, you can light up all sorts of instances for free, because these things get pushed up accidentally, at which point you need to rotate those keys quickly. And if you haven't practiced that, then you are in for a world of hurt. And if you're doing things communicating service-wise, let the browser or let the cloud provider deal with that mechanism natively. Don't open up a token for 2 EC2 instances to talk to each other. Traceability, this is all about auditing and logging, figuring out who is busy doing damage to your system. I know AWS better than the other cloud providers. You can do all sorts of fun games around monitoring and having them auto-heal. For instance, AWS has a product called CloudTrail, which logs all of your API interactions. And So turn that on. Like that's the other thing that you should do inside your AWS instances, turn on CloudTrail. But then you can do fun things like have CloudTrail log to CloudWatch, which logs to simple notification service so that if it sees that CloudTrail has been turned off, you have Lambda kick in and turn it right back on. But then you get into this, well, what if somebody turns off the Lambda function? Well, you can check that, and the rabbit hole goes really deep, and your head kind of explodes at some point. But of course, there is no such thing as a trusted network. If you think that you have a trusted network, you are lying to yourself, because you have a trusted network until your 8-year-old wants to have a new skin on their Minecraft avatar and goes to some pretty sketchy places to find it. And then your laptop, which is a secure laptop, now has sketchiness on it, and you jack into the trusted network. So Minecraft as a security vector is kind of an interesting thing, and it's completely hypothetical and has never happened. Consulting terms, best practices. Of course, there is no best practice. There are really, 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 really good practices in certain contexts. Spot the tester on the stage. So these things are always changing. So basically, you need to apply the ones that are relevant to you and ignore the ones that don't, because a best practice that applies to one industry may be an anti-pattern in your industry. But all these things, again, just to keep banging on it, are configured as code, checked into a repo, executed via CI, have the same discipline applied to them as the production code. All your security groups should be made via Terraform or whatever, so that way if if you click the wrong button to destroy the VPC or the CloudFormation stack, you can bring it back up and not have this gaping hole in your security, because it's like, oh yeah, we just created this one by hand. We didn't actually do it in the code. This one's obvious for the people that are in HIPAA or PCI or something. Do everything over HTTPS. Anything that's in transit. Of course, that means Selenium Grid as well should be communicating over HTTPS, not HTTP. I don't know if Simon's in the room. That troll works better if he's in the room. So I'm hoping that Selenium Grid 4 is secure by default, because that will alleviate a lot of concerns. But also, and in my speaker notes have this in big, bold letters, do not copy production data down into test. Stop that. There is no reason for you to do it. If you think you have a reason, you're wrong. Don't do it, because data is a liability. And if we assume that your automation environment is slightly less hardened than production, and you pull all of your data, your production data down in because we need to test with it, as the tester, do you want to be responsible for a GDPR fine? Probably not. GDPR fines start at 20,000 euros. They max out at 20% of the company's worldwide turnover. That's enough to nuke most companies. So let's not, anybody in this room, be responsible for a company failing because we're special and need to copy our production data down into test. You're not special. And you say, but we obscure it. We do fancy algorithms. At aggregate, all data eventually becomes personally identifiable. And again, security events are going to happen. Internal, external, they're going to happen. They're even more dangerous if you've copied your production data down into test. Don't do that. So yes, you are delusional if you think at some point in your career you are not going to have to respond to a security event. This is just part and parcel of working in IT these days. Do you have a plan? Do you know who you need to call? It's not the Ghostbusters. When this happens. You should know, and it should be documented somewhere. For instance, I know exactly the chain of escalation that needs to happen, and the time between those escalation points if I can't find it. And here is a tip. It's your insurance company that gets called first, then the lawyers. The insurance company will tell you when to call the lawyers. Because there's a whole section of law opening up right now of people fighting your general liability insurance. It's like, well, you didn't tell, your claim, because it's like, well, you didn't tell us until 72 hours after the breach, or a discovery of the breach, but your policy says that you have to notify us within 48. It's like, well, our lawyers didn't tell you to call. It's like, doesn't matter. It's there, it's the contract, it's signed, it's a hard number. Call the insurance company first. They will tell you, call your lawyers. But now you've contacted everybody, and you avoid that whole wiggle room of, well, we're not going to pay your GDPR fine. For more on the security stuff, I spent 45 minutes rambling on stage in the Austin conference. The talk is live. It talks about how to rotate your keys and all that stuff. So reliability stuff, failure is not an option, it's a feature. Do you have a process for restoring your test environment, your automation environment, if it went away? Somebody pushed the wrong button because you didn't have the security controls right, and you nuked all of your environment. Can you bring it up? This is the equivalent of everybody says that they have a backup process, but very few people have a restoration process. And I don't care about the backup process. I care about the restoration process. Because if you've got all these backups that you can't restore, you don't really have backups. So test this stuff. It's in a cloud environment. Spin up a second environment, or a third environment, or whatever, using your backups, using your scripts. The stuff is now disposable. You can do some fun stuff that maybe you can borrow from production or down into your automation environments, where things are self-diagnosing health. Oh, this instance is handling a smaller number of requests than I would expect. So maybe we need to light up another one and spin that one out. And this is deep diving into all the cloud capabilities, auto-scaling, and whatnot. So your infrastructure can find out its health. If it's feeling sick, it can heal itself. That is for small environments, not necessarily wanting to go at, but if you are at the Salesforce grid cluster size, this node is not feeling healthy, so I'm going to take it down and repair it, and it just happens automatically. It is fantastically fun stuff, where fun is an interesting definition of fun, but I think it's fun. Standard sort of cloud stuff. They talked about this in the grid workshop. It is far better from a cloud perspective, to have a whole whack of small, pieces in play than a monster instance. So if you have a grid, yes, like an M4 extra large could support 20 concurrent browsers, but it's probably better from an infrastructure perspective to have those 20 browsers spread across 5 small instances or extra small instances, especially if you get into general practices of 1 browser per CPU core per gig of memory. So this is this applies as well to your production infrastructure, but it certainly also applies to your test infrastructure. So often you see, well, how many machines should we have in our cluster, in our grid? Like, tell me what the capacity rules of thumbs are. And the answer is all, I don't know. Like, I can't tell you what your load of your profile is of your application. So you need to measure this stuff, and then again, you can scale automatically. This is the elastic in elastic computing. Things expand and contract as necessary. So measure the performance of your grid machines and your application under test machines, and when they fall outside of bounds, then scale them automatically. These are the cloud tools that are given to you. Use them. But when I say measure, I don't care about things like CPU and memory, because guess what? Those factors mean nothing to your end users. Absolutely nothing. They care about things like number of logins per second, how many transactions can I do, the duration it takes for search results to return. So measure those things. Measure them in rolling 5-minute averages. And when they fall out of that, then scale it up until they're back in. I learned this trick from Etsy. I'm sure they've got lots of posts on it in their Code as Craft blog. It took them like a year and a half to get all their scaling stuff worked out right, because like Black Friday made it look like their servers were under attack, but it was just like, it's just shopping. So they just need to have that as their alarms trip during non-Black Friday days in this. But this profile is, if it falls out of that profile on Black Friday, then bad things are happening. But this also means that you're running realistic load scenarios. If you are running against a single application under test, one at a time sequential automation scripts, unless you have a really slow website or a low traffic website, which point I'm sorry because your company's going out of business, running your scripts one at a time, back to back to back, is automation theater. You're not actually testing the application. You're just like, oh yes, when the site is completely barren, the login page works really, really fast. But if there's 1,000 people on your site at once, it's gonna fall down. So we've got cloud computing. We can scale this thing massively. Most of the test runners can scale pretty large. And the next generation are built with parallelism in mind. All right, 14 minutes left. We're almost there. Again, harping on this stuff, your infrastructure should not be a work of art. Every single instance in your automation infrastructure should look the same. You have not logged in and made it like this special, like this is my Picasso of servers. It can go away, come back, nobody's feelings are hurt. It should just be boring, like painfully boring. When I started doing this, like 20 years ago, we were afraid to reboot, to reimage some of our machines because it's, well, did we do this setting? Did we not record it? And so it was like, do not touch this machine. We can restore any of these ones, do not touch this one. You don't want to be in that scenario. Any of this stuff can and will go away without warning. So bring it back up. It should be painfully boring. Efficiency. So this one, again, this harkens back to me being old. Basically, the idea in this one is you as infrastructure or as testers don't need to understand how to install MySQL and tune the heck out of it anymore. Amazon wants you to use RDS and all their hosted things, which is a useful thing to be promoting. I used to be an expert at installing LDAP servers back 15, 20 years ago. I knew all the settings on all the major vendors to set these things up. And I would spend a lot of my brain power worrying about that stuff. Now, let somebody else deal with that nonsense. So all you should know, or we're getting to the point where all you need to know is how to interact with services in your infrastructure, not the nuances of setting it up and profiling and all that. And that's only a good thing, because it lets your brain do other stuff. This one I've seen some interesting side effects from. If you have your production infrastructure distributed globally, why not have your testing infrastructure distributed globally? Having your test infrastructure run in Virginia when you've got servers in Virginia, Oregon, Sydney, and Paris, and with weird dynamic load balancing between them, you're not really testing production. You are testing something that has characteristics of kind of production, but you're not actually mimicking what your end user is experiencing. Again, you're stepping close to automation theater in there. Amazon, of course, wants you to use serverless because serverless all the things. So go ahead, use serverless, or don't. Again, I really don't care. For me, serverless in automation environments is really interesting when you start creating things like service doubles. Like maybe your automation doesn't need to hit PayPal every single time, every single script. So just write a little Lambda function that mimics the APIs that are going to PayPal, and that way you're literally only paying 0.0003 cents for that pretend hit out onto the internet, rather than having it sitting in an EC2 box that's live all the time for $45 a month. So that's just one way that you can use serverless. Again, Amazon wants you to experiment more. Try all the things. It may not work out, but you're still going to give us money. So work with the production ops team. Actually do that whole DevOps thing that everyone wants to be buzzword compliant with. Have them try their automation, their infrastructure changes in your test automation environment while running the tests. See what falls down, because that's probably what's going to happen in production. This one is basically figure out what you need to do and use the right tool to do it. Not very, the mechanical sympathy is a fun way of saying that. And then Amazon goes on to explain how this right tool can be used in a million different ways, so give us more money. But figure out what tools you need and then use them. Amazon provides lots of them. GCP provides a lot of them. The overlap's probably 85% at this point. Azure, same thing. We might actually make it in time. The last pillar, cost optimization, which is going to become a much bigger pain for people, especially as you proceed in your career and get into management levels. If you are the low-level grunt that is just grinding out scripts, you may not care about this, but as you go up and start to have budget oversight, this one becomes really interesting. Especially given that there are entire companies now whose job it is to take your raw bill from your cloud provider and tell you what the heck it means. So figure out your usage patterns and automate them. If everybody goes home at 5 o'clock because you aren't in a death march or whatever, then auto-scale your entire environment down to 0. 0 is a valid number for auto-scaling amounts, so then you aren't paying for that infrastructure. If it's not running, you're not paying because it's on an hourly basis. And then spin it all up automatically at 7 o'clock in the morning so that when people are going to be using it. Or you could have your Jenkins job or your CI server light up your environment, or if your containers or whatever, run the scripts, destroy it. So figure out what your company's usage patterns are, automate them for cost optimization. And an important part of this is everything, I forget what Google calls them, but Amazon calls it tags. Tag everything that's involved in your automation, because when you get your bill, you can filter it based upon those tags. So you can see how much it's costing, and set up billing alerts, which it can be challenging depending on which architecture you're choosing. The last thing you want is a big surprise at the end of the month in your bill. You can set up billing alerts saying, hey, your bill just magically hit $5,000 for the month when it should never hit this, or it should hit this at the end of the month, and you've hit it 3 days into the month. There's something strange going on. Find out about that early. So again, this becomes more site-specific stuff. What are you, willing to pay for? What are you doing? What measure of efficiency are you optimizing for? Is it time of information coming in, or is it the confidence level of the information that you're coming in? Because you can spend more money to have the results come in faster. But if you don't care about the speed of the results because you just run overnight, then maybe you run deeper tests and have more confidence, like they talked about at the keynote. You can pay a spectrum depending on what you're optimizing for. So figure out what you are optimizing for. Again, shocking, Amazon says, you don't need data centers, put everything in the cloud. So this discipline says, stop spending money on data center operations. I would say, except when you have to, right? What if you actually do need a physical device farm that has, well, Amazon has a device farm, sure, but they don't have SIMs in them. So they don't actually have a phone number. So they can't actually receive SMS messages, which is my personal use case. I'm trying to get Hugs to build me Tapster as a service to solve this, but that's still a physical thing that needs to sit in a data center. So at some point, I'm going to have to pay for a cage somewhere. For my fully cloud automated environment. Again, this comes back to tag all your stuff. How much does our automation cost should be the easiest question in the world to answer. It's like, well, let me go to my bill, and I will filter out all my infrastructure expenditure and do a sum. That used to not be the easiest question to answer. I used to have a rack of machines sitting in a data center. I don't know how much the power is to run into this. I don't know what our replacement parts that are sitting spare cost. How do we amortize those out over the lifespan of the server? Whereas in a cloud environment, you are paying by the hour or you are paying by the month. So it should be super easy to answer that question. And the last one, again, this comes back to Amazon wants you to use RDS instead of MySQL. And that is actually brilliant because your time is more expensive and is more valuable than compute cost in 99.99% of the time. I will happily pay more to have somebody take a headache off of my plate. Like my production environment is 100% in Amazon. Yes, I know how to configure up and manage MySQL. I know how to configure and manage Elasticsearch and all these things. You know what? I pay the bonus to let somebody else deal with that headache. Same with your infrastructure. If you have the budget, of course, let somebody else do it. And if you don't have the budget, go to your boss and say, I would like the budget because that allows me 2 more days a month that I don't need to worry about my infrastructure. I don't need to worry about patching. And here's this other instance that doesn't need to happen, doesn't need to exist, which saves us some money and allows me to do the thing I'm actually supposed to be doing, which is writing tests to increase the value of our application to our end users. So, rhetorical question to just wrap up the presentation. Are you well architected? Some of you might be, some of you might not be. But like I say, for reals, print out the framework, put it on your desk. If you're just bored or you're waiting for a build to finish, you could be like, oh, well, today I'm going to think about my cost-effective resources. And just look at your environment. There is enough stuff here to keep you busy for the rest of this month, or the rest of this year, and probably most of next year as well. So my plan, because I just flew through all this stuff, the numbers changed color as you're getting close to the end of the talk. I'm going to the office hours room because I'm also fighting a cold and need to sit down. So you can, after the session, pick my brain over there. But with 2.5 minutes left, I'm done.